What's up, everybody? My name is Jason Novies, and I'm here with my fellow developer advocate and co-author, Josh Wood. Earlier this year, we put out an O'Reilly book named Kubernetes Operators. And over the past couple of weeks, we've been doing these learn sessions to give some very fast, very high-level overviews for what to expect when you start to work with Kubernetes operators, what to expect from the book. In the first session, we talked a bit about just generally speaking what an operator is, how they tied into Kubernetes and OpenShift. Last session, we talked about the tooling. How do I create my own operator? What options are available to me in terms of programming languages, in terms of other tools? Today, we're actually going to talk about how you use an operator, give some nice tangible examples and an actual demo of an operator in action to help really wrap up the concepts we've been presenting over the past couple of sessions. We talked in the previous sessions about how it is a paradigm of how you can write applications that will manage your specific domain applications. So for example, every application has to go through a series of steps or a series of life cycle. You install your application. At some point, you're going to have to upgrade it. And that upgrade can get tricky. There's a lot of moving parts. And if you have to hand your end user a series of complicated instructions, something's going to go wrong. But operators do more than just the installation and upgrades. They do your day two management of keeping an eye on your application, understanding when it needs to have certain health operations run on it, certain scaling operations. So it is this ever-present living application that keeps an eye on your application and keeps it running for you. Next slide. I love this quote. This came from a teammate of ours when he put these slides together originally, or a version of these slides, and it holds true. These days, the industry is moving more and more towards operations. We see it in QA. We see it in these DevOps world where we need to automate everything as much as possible. We've also done spins on this talk where we talk about taking a single person and encoding all of their knowledge into software and that's what an operator ultimately is. In other words, we have to have this stuff in code. We can't wait for the 2 a.m. text message to reach your ops manager and then they can figure out what went wrong with the application. We want to have this in something that can respond in seconds and actually interact directly with the Kubernetes API and encode all of that domain-specific knowledge into code rather than into a person. Next slide. So from here, Josh is going to take over and talk a little bit about what sorts of operators are available today, how you find them. And then, like I said, he's going to go on with a demo of how we actually use an operator.
Yeah, that's right, Jason. And so one of the ways I like to think about this is we all came to Kubernetes because of its ability to automate the basic management of simple stateless applications. If you're running a web server on Kubernetes and a copy of its replicas, one of its replicas falls over, it's very easy for Kubernetes to just start another one. In fact, it could almost start a different web server altogether, replace a caddy server with an Nginx server. So long as they both can respond to HTTP, this simple stateless web server doesn't really have anything to preserve between user sessions or any data that needs to persist. So essentially the pods that represent it as a service running on the cluster are fungible. You can replace any one with any of the other. And as we've looked at, especially in the first episode in this series, that model, as great as it is, doesn't extend to the complex stateful apps that usually somewhere in our application at some layer, whether it's at the front or the foundation, we do have persistent data. We do have user sessions or user state that needs to be preserved. So those kind of stateful applications are not within the realm of what Kubernetes knows how to manage and automate by itself. They may have authentication assets or knowledge of endpoints of other members of a cluster that they would like to join. For example, if we're talking about a database server running as a pod that wants to be a member of a cluster, that database server needs to know about write leaders and read followers and those relationships. It may need authentication assets in order to gain access. And the other members of the cluster need to be informed about it and its endpoints. A lot of that work is commonly left to a DBA or another ops team member, an administrator who manages that database cluster of PostgreSQL or MySQL or Redis databases, or it's left to an admin team member who manages our persistent file stores, like a Ceph file system cluster providing persistent storage to other applications running above it on a Kubernetes cluster. So in the first two sections, we went over those ideas and reinforced them, and we took a look at how we build operators. Today, we're going to step back from that and take a look at what using existing operators from vendors, partners, community projects, looks like on Kubernetes clusters, including Red Hat's OpenShift Kubernetes distribution. So the first thing we want to point to is that even if you're not interested in building operators, you can use them today as a way to ease the self-service consumption of foundation apps like the databases and file system stores that your applications rely on. That ability to discover and install operators is represented by the image we see on this slide of the operatorhub.io website, where you can find operators to pair with an OLM and bolt them onto any Kubernetes cluster, not just Red Hat's OpenShift. And that same operator hub concept is morphed and modified in Red Hat products like OpenShift, where we talk about the in OpenShift operator hub that we'll take a look at in just a moment, and the Red Hat marketplace, where licensed vendor programs are often found for distributors of non-community projects. So we can find a combination of both community products, our projects, Red Hat projects and products, and vendor products in Operator Hub and in the marketplace and the Operator Hub within Red Hat's OpenShift. But it's important to understand first, operatorhub.io along with OLM can be bolted on and used in any Kubernetes cluster. And that same modularity allows you to build catalogs of operators that make sense for your organization or for your individual development teams, and that might package together the software that's needed to begin and initiate any project within your team or your organization. So the real key idea here for using operators today is easy self-service for operator back services. So let's go over to an OpenShift cluster and take a quick first look at how easy it is for admins to enable and then developers to self-serve operators and their operands, the applications they manage across their whole life cycle. Now we're looking at an OpenShift Kubernetes distribution cluster of the version 4.6 series. And the first screen I have up here is actually something I've mentioned in a couple of slides and shown a little preview of, and that is the idea of an operator hub within OpenShift. And what we're going to take a look at here is the kind of user experience, both for operations or admin teams and for developers self-servicing individual instances of the operands, the applications that the operator manages. So one of the kind of canonical examples of operator functionality that sort of shows in a way that's big enough to be interesting and small enough to very easily get one's head around is Etcd. And you may have heard of Etcd. It's sort of the lightest weight distributed database you can imagine. We really think of it as a key value store, but that's what it means, is that we can put keys and values in a system that has multiple nodes that maintain a quorum and a consensus based on the RAF protocol. Because of that distributed systems legacy in engineering, Etcd is actually found at the center of a lot of modern cloud native projects, probably most famously at the core of Kubernetes itself, where a cluster of Etcd nodes provides reliable storage for the API data and persistent state. So when I change the number of replicas from 1 to 3 for some service and set of pods that I'm running on a Kubernetes cluster, the actual record eventually is communicated through the Kubernetes API and written into Etcd storage. Vault and a number of other community projects in the distributed space have Etcd at their core in a really similar way. So it's a common enough application that if you're building some kind of application front end, or especially a distributed application that needs to coordinate configuration or some other consensus-based persistent data, Etcd is a really frequent choice for that. Etcd as itself runs in a cluster and can be a little bit difficult to manage, especially as Adobe's hinted at, in the space of upgrades or unexpected failures. An Etcd member needs some information about authentication and endpoints in order to join the existing members of an Etcd cluster. So Kubernetes can't know all about managing Etcd and what to do when an Etcd node falls over, or we want to expand or shrink a cluster in response to increased or decreased demand. But an operator can teach a Kubernetes cluster how to manage Etcd on our behalf and let us just use the etcd service for the part that as developers we're most concerned with, which is storing our data or shared application configuration there in a reliable way without becoming expert etcd administrators who know all of the ins and outs of running, upgrading, and maintaining etcd clusters through their whole life cycle. So within OpenShift, and we'll show you also similarly how you can achieve these same results on any Kubernetes cluster with OLM and the operatorhub.io website. But within OpenShift, we have the idea of an operator hub where we can discover the kind of foundation services we need. And as an admin, the experience looks a lot like this. I've filtered through the many items from around the community and from Red Hat and the Operator Hub to drill down to etcd, our distributed key value store. And I'm simply going to install the Ecd operator. Now, we won't have an Ecd cluster yet. What we will have done by installing the operator is enable all the developers on the team that I'm an admin for to easily create their own instances of Etcd when their applications require such a thing. So with just a click of a button, I'm brought to a screen where I can make some choices about how we're going to configure the operator itself. And in this case, I want to choose among the update channels for eventual upgrades, because one of the things that the Ecd operator does is apply Ecd upgrades to our Ecd clusters over time, keeping us up to date with security patches and new features in Etcd without requiring a lot of effort and expertise on our parts. So I can kind of choose an update channel. This is similar to what you might think of choosing update channels in Chrome OS or your browsers. How far in the future do you want to live, or do you want something stable and approvable at each upgrade step? Generally, operators provide those choices in this kind of initial configuration screen, like the one we're looking at here for the Ecd operator. I am going to choose to restrict our operator to watching resources just in one namespace on the cluster, the Ecd op namespace that I've created in advance, just so that we can restrict things there and find them easily. So again, posing as an administrator here on this cluster, I can kick off the Etcd installation of the Etcd operator and wait just a minute for the operator to be in a running state. And once it is, and we see that we've succeeded in deploying the operator, by drilling down here, even in this graphical user interface, I can create and manipulate Etcd clusters, backups of those clusters while maintaining the service, and restorations from those backups, all managed by this operator instead of intensively and manually managed by a human expert who maintains our database or our Etcd clusters. So the first thing I want to do is spin up an Etcd cluster. So I can actually do that right here again with a graphical interface where I can make a few choices. If I want to drill into the details or have very specific requirements, almost all operators give me the opportunity to edit the YAML for the custom resource we're going to create. And this brings us back to the key ideas of both the first and second segments in our Learn series of what operators really are. And they're a way to describe the internal specific state of an application to custom controller code that knows how to maintain the desired state of that application and its specific internal resources, processes, and techniques. So with Etcd, we're looking at just the size of our cluster and our version that we would like to deploy at the minimum. Back here in the GUI view, I have exactly the same choices, just represented in a little bit easier way to consume. Now, in this case, we're posing as a developer. Because an admin has installed the operator on our cluster, I can create Etcd clusters to back my applications very easily and in a self-service manner. And then the Etcd operator will take care of upgrades, service failures, and up and down scaling of that Etcd cluster on my behalf. So let's go ahead and create that cluster. And then immediately, because operators make the applications they manage a first-class API entity in the form of a custom resource, we can drill into a thing with a kind of Etcd cluster and see details about this cluster as it comes up and begins running. We have one pod running, and we're waiting for the other couple to come up. And once we do, we'll have a full Etcd cluster with the basic requirement for Raft quorum running. And we'll look at how we can knock one of these members of the cluster over and see the operator handle both the scaling up function and recovery from failures by handing a new member of the Etcd cluster the assets and resources it needs to join the existing two members that are left still running. So I can actually drill down in OpenShift into just to look at the pods running in our Ecd Operator um, namespace. And we can kill off one of these pods in just a moment. I'll actually come here through the operator management screens. So we can look at our Ecd cluster. Here it is. It is comprised of a number of services and pods, as we can see. And I can actually come in here completely unexpectedly and kill any of these pods or delete any of these pods. And what we'll see is as that pod terminates, in the usual Kubernetes reconciliation loop that we're used to from stateless applications, the Kubernetes Ecd operator will examine our desired state of having 3 members of our Ecd cluster and begin immediately taking actions to restore the actual state on the cluster back to that desired state. And you can see we've already replaced the Ecd member with the necessary configuration it needs to rejoin that existing cluster. Meanwhile, our Ecd service has continued to be available to applications, and we can progress along in our work. And all of that happens without anybody having to become the designated office Ecd expert. We can offload that work, much of it, to the Ecd operator. So to go back to the operator for just a moment, we can also offer the quick reminder without digging deeply into the future or into the feature that the Ecd cluster operator comes with features for managing backups and the restoration of those backups. And of course, like we assume for most basic functionality represented by production-ready operators, handle not just the installation and recovery that we looked at, but also handle upgrades between Ecd versions of our cluster members in our little Ecd cluster over time. So that's a rapid look at the Ecd operator running on an OpenShift cluster and allowing admins to create easy self-service distribution for Ecd clusters to the developers in an organization or a team, with the operator taking on the onerous heavy lifting of administration tasks like deployment, distribution, scaling up and down, and recovering from failures. And I want to stress that none of this as a CNCF project is limited to OpenShift, Red Hat's particular distribution of Kubernetes. In fact, if we take a look at operatorhub.io, we can see a recapitulation of very nearly the same list of community and vendor projects and products, along with projects and products from Red Hat itself, that are represented here in a way that if you bolt on the operator lifecycle manager to any Kubernetes cluster of new enough vintage, you can consume operators from this catalog represented at operatorhub.io. For officially licensed products with a business relationship attached, there's also the Red Hat Marketplace for consuming a wide array of databases and other foundation software that you need to build your applications atop in an operator managed, simplified way with a nice GUI for having developers self-serve in a sort of a cloud native style, the foundation and component apps that they need when they're building their own applications. So again, while we have looked at managing an operator inside of an OpenShift Kubernetes cluster, you can also get that same technology because of the open governance and development represented by the CNCF framework in the operatorhub.io and OLM combo on any Kubernetes cluster. So with that look at a direct example of using operators to manage a common, necessary, popular foundation service like Etcd, I think we've at least given a good outline and a high-flying overview of how operators as an admin and user experience are really about providing easy self-service on Kubernetes and OpenShift clusters for your applications that you're shipping to customers and to other members of your team who are working on developing software with you within your organization. And that's really the key user experience that all of the technology about how, what, why, and how to build operators we've discussed in the first 2 editions of this Learn series are aimed at, is this user experience of self-service for complex stateful apps on Kubernetes clusters. So once again, as we come to an end of another Kubernetes Operators Learn series video, we want to point you towards the book that Dobies and I wrote together with O'Reilly a little bit earlier this year, and that is at the bottom link here at bit.ly. You can pick up a free electronic copy courtesy of Red Hat's OpenShift Kubernetes distribution. We'll also definitely point you towards joining community efforts around the operator framework at the CNCF, the OLM and SDK, the two components that comprise that framework. And you can find the communities and development information, GitHub repositories, and all the other info you need from documentation to demos and examples at operatorframework.io, operatorhub.io for actually consuming operators on any Kubernetes cluster. And definitely check out the interactive lessons where we spin up a cluster for you and let you play with operator technology on a real cluster that you can find at learn.openshift.com. Once again, we hope that this video and indeed the whole Learn Kubernetes Operators video series has been a useful, rapid overview of Kubernetes operators, both the pattern and the technologies and tools that represent the implementation of that pattern on Kubernetes clusters. So for me, Josh Wood, and my Red Hat colleague and co-author, Jason Dobies, I want to say thanks for viewing, and find us at any of the URLs on this resource screen to learn more and continue the community efforts towards building operators into the way to manage complex stateful applications on Kubernetes clusters.